Testing, testing. All right, I think the volume's all good. All right, so this is Smart Builds, and this is the second channel. So in this stream, what we're going to be doing is building a delivery robot. In fact, it's actually being built, but we're going to be demoing it for the first time on the live stream. In fact, the whole premise of this robot is it's going to be controlled via live stream. But let's not waste no more time and let's get straight to it. Greetings, hi, welcome. My name's Evan. Thanks for joining this live stream, and if you're watching this in the future, greetings from the past. So, what we're going to be doing in this stream is building a delivery robot. To be honest, it's my very first live stream on YouTube, minus the actual test streams, but to get the audio right, it's my very first official live stream. And the reason why we're doing it on the second channel is mainly because I just wanted to make sure everything was correct with this robot, especially with this channel is more just involved in R&D kind of stuff. So it's going to be a lot of, if you like to watch people wiring, or if you like to watch me figure out some code for over an hour or so and get nowhere, this is the channel for you. But it's going to be very raw. You can speak whenever, we can chat if anything. This channel is just mainly to be a bit of an update channel, whereby we can actually get into a smaller community as well as interact with each other. So that's the reason why we've done the second channel. This would also just fill the gap in between the uploads from the main channel, because there's quite a bit of updates, but it's always done in the background. But it's something I like to show in the future. So hopefully this channel would help meet that need. So what are we building today? What have we built and what is to be shown? So the next project that's going to be on the main channel is going to be a delivery robot. Yes, a package delivery robot. In fact, why not show you straight away? So this is the delivery robot here, and it's called Droiid. Now, Droiid is a package delivery robot, which is designed to be autonomous. At the moment, it's not autonomous at the moment. In fact, what we've controlled it and what it's being controlled to be is that we can control it from any part of the world via YouTube chat, Twitch chat, or any device connected to your phone. So for example, it's got two main features that we can control. First of all, we can interact with the real world using text to speech. And secondly, we can also control the robot using almost a game command. For example, W go forward, A going left, D going right, and S going backwards. So that's the whole idea of the actual robot itself. You could probably see the light vest from a few months ago. So that's the whole idea of the robot. In fact, the robot is just below me here. So what the robot has is that it has its own LED lights, blue LED lights. In fact, the robot was inspired by the whole Amazon Scout as well as the Starship robots. The whole idea is it's kind of got a spin with the Wally's best friend look. As well as it's also got this kind of white and black, which is kind of inspired by, the Stormtrooper, the original Stormtrooper look. So this you can see on the robot is actually on the bottom right, you can see an actual camera view. And this camera is actually coming out of the lens of the robot. In fact, if I just stick my hands out, barely, you can see my hands on the robot. In fact, you can even see the latency. It's not too bad. As I stick my hands out, you can see that it's definitely under a second in terms of basically the response. And to be honest, this was the most important thing because we need it to be as responsive as possible. If we're halfway across the world, we'll still need to control the robot. So let's exactly go into how it works. So I'm gonna control it from my screen, and this is on my computer. So for example, this delivery robot use case is to go to the shops and get me some food and come back. We can go and in fact, let's say the very first word, it's got text to speech. So I can take from my computer and the robot will say something. So,
hello world.
I'm not sure if you can hear that, but it said hello world, which is fitting. Let me just try that again. I hope you can hear that. But the whole idea in this case is that we'll say, if we goes to a shop, imagine it going to a shop, we can interact it with say,
Hi boss, would like to order a meal.
so we can go to the actual shop and, you know, the UK, we just go up, say, boss, what's up? We can get something, for example, a takeaway. Then this will be placed within the robot and the robot can then be controlled to come back home. Now, the whole idea is for it to be autonomous at the moment, but in the meanwhile and in the middle of it, I thought it would just be great to actually control the robot. It gives a more interactive feel with it. So that's the text to speech. In fact, we can say something. So say, hi, this is a live stream.
Hi, this is Livestream for Droiid, the robot.
So in fact, I should mention that the robot's name is Droid, and that's with 2 I's because Droid, why not? It sounds startup like. So that's the whole idea. On the very right, you can see is a mini version of this robot, and in fact, this is the exposed version of it. So rather than 4 wheels, 6 wheels, it's using 4. And it's got the same actual electronics, and in the video that's going to be coming up in the actual main channel, we're going to be going more into the detail on how the robot is built, what motor drivers are we using, what motors, the code, and how the whole thing comes together from start to finish. We're building the robot from scratch, and this involves how the Raspberry Pi interacts with the Arduino, how the code, how the Raspberry Pi gets the commands from our server, which will be an EC2 instance, and how this is running on a microservice. So it's going to be quite an in-depth video, and hopefully something that would be interesting. So with that said, let's go into actually controlling the robot. So as said in the actual video just earlier on, we have a keyboard, right? If you can see, and if I can focus this without cutting the live stream, you can see that we got these WASD commands just here. If I can, I'm doing this invertedly, but W goes forward, S goes backwards, D goes to the right, and A goes to the left, a bit like a game. So we can control the robot, and that's the whole idea of it. I need to manually actually fix this camera. So this red spot is basically because I'm using a mirrorless camera, and then I actually need to record the actual input for it to stay on. So that's the reason why we got that red dot, by the way. So let me explain how this works. So we talked about how we can control the robot. So say hello.
Hi.
This is done as what we're doing is we're sending an actual JSON payload to a EC2 instance, basically a server of the Droid server, and this is sent to the Raspberry Pi, which interacts with the Arduino. we'll talk about this more, but let's actually control the robot. So if we want to go forward, as we said, we type in W and it goes forward. And notice how you can see the camera starts to move, right? If we type in S, which is backwards, the robot starts to move. And it looks like it crashed into our little friend at the back. Now the whole thing is that we can control the robot from our actual home. We can control it not just from our home, but anywhere in the world, so far as we got internet connection. So the actual platforms we can use is Twitch. We can use not Instagram. We can use Twitch. We can use YouTube, live chat features, and we can also just use our actual local terminal. And that's what I'm using at the moment. I'm using a local terminal to send these commands. So that's forward and backwards. We can also turn left by going A, and that turns slightly to the left, and D would turn to the right. So that's the whole idea of the robot. So what I would show you is just a more in-depth look of it, because it's kind of from an aerial view. So let me just show you specifically how this looks. I'm just going to crank up the gain so you can see, but you can see that the robot itself is, this is how it looks. It's a 3D printed robot. It's got 6 wheels, and it's also got some backlights, as you can see here. Now, what will happen is that we will be able to see in the paper, inside here is the actual they're just electronics here. But what we're gonna have is an actual platform cover just there, and then we're gonna have a bit of thermal insulation, a bit like a delivery bag or some kind of food bag package, where you can put your actual payload in. For example, if it's food, it keeps it insulated. And let me just close the window. If it's food, it keeps it insulated as well. So that's the whole idea. Now, this smaller robot is what we're going to be talking about, which is going to go into more detail. We're going to go into more detail in the video, specifically how we got the motor drivers. If you can see here, how we have the Arduino, how we have the breadboard. This is not the battery we're using a LiPo battery, and how this will control these 12-volt motors. So this is what we're going to go into in more detail. So let me just come back to my and turn the gain down a bit. So I hope that made sense what we're gonna be doing and how we're gonna control the robot. So the whole idea in subsequent videos, and of course this is still version 1, is that we're gonna be able to make the robot move around. So in fact, we can make it move forward at the moment, so closer to the robot itself, the other robot. You can see it here. You can see that if we go backwards, you can see the red light. Now we can also program the backlights, so it can have almost like an Audi indicator lights. So if I move slightly to the left, observe how the lights turn. Okay, so it's a very slight. We're gonna program that. I'm gonna program that to improve it, but it's very, very brief. But there's a yellow light that shows. The whole idea here is that, yes, so you can see it does it after the moving, which is counterintuitive. But the whole idea here is that we're going to be able to control the robot, as well as it's going to give ongoing pedestrians an indicator of the intentions of the robot, if it's to move left or right. So we can play around with it. Now, I'm going to slightly turn it to the left. And to the left. It looks like we had a little bit of a crash. I didn't control it in time. So what we're going to be doing is just showing you specifically how the robot functions. So let me just log in. And this is a bit of just a live stream, so there's nothing really structured at the moment. We're gonna have more of an official stream on the main channel, which will go into more detail on how this robot is controlled. So the question may be, how is this robot controlled? Well, first of all, let me get the robot in view. Hopefully it can move without crashing this time. All right, so this is the robot in view. So how is this robot controlled? Let's go back to the face cam. So what I'm gonna show you right now is a small diagram to explain how the architecture of the robot is. Now the diagram I'm going to show is most likely going to be outdated by tomorrow because it's always changing. So let's have a look at it if I can get it up. So let me show that. So it's on the GitHub, so let me just make sure I can actually get GitHub all up. While we wait, let's just show exactly how the code works. So in fact, we have the README here, so that's even better. In fact, let's have a look at the actual structure of it. So if we just actually preview the README, this is what we're looking at. In fact, you can see here, these are the endpoints. No, in fact, you can see that in the Droiid server, when this is running on Docker, we have specific commands that are sent. You can see here that it's forward, reverse, stop, forward. So if you recall, we did a right and we did a left and we did a forward and we did a stop. Now we can stop the robot manually from our keyboard using X. So in fact, the whole overall, we have WASD for of course our movement commands for just gaming. It gives it that gamification and nice dynamics, as well as X to just kill all commands, so it's just stationary. So these are the current payloads. So this payload is sent to the Pi server, which it's done in real time based on the timestamp of today. It looks like we're using a different time zone here, but you can see my username that has sent it is Eben. So it's a way of identifying who is controlling it. So theoretically, that means, yeah, you can control the robot as well from the live chat as well. Of course, it's going to be quite interesting because it might get hectic. So most likely we're going to probably do it in bits. So if a moderator is able to control it, then we can slowly expand it out. And the whole idea is that it's going to be a crowdsourced controlling of the robot. Now you may be asking, like, what about if there's so many different inputs? The whole idea is the most upvoted, well, for lack of better words, the most upvoted or the most common command within that second period of a window, or like 10 seconds, that will be the next robot command. So for example, if there's 10 people who type in forward, or let's say out of 10 people, 7 people write forward, 2 write left, 1 writes backwards, that forward command is going to be controlled. So the whole idea is making live streams more interactive. So this is how we're going to start it off with. So let's go into more detail on what the robot is. As you can see here, I've just written a little readme that the robot will go forward, the robot will turn left, and the robot will go backwards with these commands, as well as it can turn right. Now, to make the robot talk, in fact, let me know if you can see this. I think it's a bit too small, so let me zoom in. All right, let's have a look here. Hopefully you can see it. So anyways, Droiid is a in real life robot drone control. I wrote this quite a while back, so I don't know if this changed, but Droiid is in real life IRL robot drone, which is a ground drone controlled by Livestream. Controlled by our live stream community. So this is both on Twitch and YouTube, and the whole idea is to perform tasks indoors and outdoors. For example, it can automate tasks indoors, but even though it's quite large, as well as users can control this via the live stream. So for example, what I just showed is a demo of us being able to control the robot. But Droiid is not just a specific robot here. The whole idea is that the whole server that we've built, that I built, is going to be almost connected to several nodes. So in fact, what we see here, as you can see here, just this Droiid, this is just one node. Let's call this node 0. This is Droiid 0. However, we can add several different droids onto the server. So that means we can interact with different server droids. So imagine if we could interact with half the community can control the smaller robot, half the community can control another version of this robot, let's say this robot in fact, and then we can do some events with it. For example, going around a circuit or so, and this kind of opens the whole idea of like an interaction between, it kind of blends the whole idea from typically what we have when we are live streaming. Okay, let me see, let me just start that again. So yeah, I had to restart it again. The whole idea here is that when we're live streaming, typically someone's always talking and the person on the other side, the viewer, is always watching. But what about if we could ideally interact cut the barrier in between, and a user can also interact with the actual streamer with an appliance or so, which will be the robot itself. For example, we can do some kind of sports like robots. Let's call this robot sports for lack of a better word. It can open the whole kind of field for that. But right now it's a delivery robot, and that's what we're going to focus on for the subsequent videos. But this is what it can be, and this is probably where it's probably going to go during now till probably the end of the year, early next year, as we go into it. So how do we make the robot talk? Ideally, we say as the command. So typically, we'll have appendix. Basically, there will be like a command before we say it. So it'll be like say message, and the comma is almost a separator. We can use a colon, but I just use a question mark. I'll probably change that to a colon soon. But the whole idea is say, and what comes next is hello, my name is Droiid. So the robot would say everything after say. So the say command ideally lets the robot know, okay, I need to say something. Now this is the whole idea. We have this command message. So we have command and we have the message. Now the command can be other things, for example, light comma on or so. So it kind of opens this whole idea of interaction via live stream. So going into it, how this was built was that I used the Raspberry Pi 4. I used a 2 gig version. I'm sure that if I use 4 gig, because I'm streaming on the actual Raspberry Pi, as you can see here, if you can see, if I'm streaming on the actual Pi, you can see the camera view here. We could probably improve it, and in fact we can even stream on Twitch directly from the Pi, as you can see with the camera. Now just going back to our actual coding, what we see here is basically the actual files and how to install it at the moment. Right now, the repo is something in development, so it's not available now. So I'm just doing all this kind of putting all this together. But what I want to show you is the actual diagram, and this is the diagram we have right now. This will probably help explain everything in general, and it's how it is at the moment, but by tomorrow, by next week, it's most likely going to change slightly. So this is something that's ever evolving. So we see here that we have the actual robot. So in fact, you can see in the thumbnail the whole idea of what we have. So I just want to show you I'll show you the thumbnail, but if you can have a look at the thumbnail, it shows a robot, it shows an actual laptop, and it shows the platform you can select. You can select YouTube, you can select Twitch, and what's just been recently implemented, hence why this is always changing, is that we can control it remotely using terminal. Basically, I've just basically made a small Python application that interacts with the robot. So how this happens is that we have a user interface. Now, you may be wondering why Twitch, why YouTube? To be honest, it's because it's interactive. In fact, I actually did make a React app for it, but the thing is, getting people to go onto a website to control its bad user experience. So why not leverage a billion-dollar corporation, Twitch, YouTube, and their low latency stuff, and why not use that rather than reinventing the whole wheel? Not that I could, but it will just be better. Of course, this is one project and not something that we want to spend so long on, because we want to make more improvements, so no point in staying on the actual user interface. So that's why we're using Twitch and YouTube, because it's just got great built-in user experience, as well as got a way of as it's trusted, and it's also has great usability as well. So that's the whole reason why we're using Twitch. We could have used our phone or so, but our phone is quite limited because I can't just use my phone. If I use my phone, it's going to be a terrible experience if we just have some kind of local host. So the whole idea is that we're using Twitch and YouTube. Main reason why is because it's got different we can use different phones, we can use different devices. You can go on Twitch and YouTube on your phone, you can control it through your phone, you can do it on your laptop, you can do it on your PC, you can do it on your tablet. So it just gives a whole user interface. So the whole idea of using YouTube and Twitch is we're leveraging already built platform to interact with our robot, as well as it's got an inbuilt customer user. I mean, YouTubers, it's got people who watch YouTube. So it's kind of an interesting way to interact with. So how this works is we type in a command. Let's say hi. This is sent as a JSON payload, where in fact we're using webhooks on YouTube and Twitch. So we're always listening to a message. So for example, if what we're using is basically we're using a small little Python application that's listening to an actual live chat on YouTube by the channel ID. So this is using our channel ID, and when it uses our channel ID, it's just listening to all the messages. And for example, if it sees a command saying say hi or W move forward, it starts to make it then accepts that message. So that means people can normally chat on the live chat as normal, except from when the server sees the specific command say or W for forward, D for backwards, and the whole game commands. So that's the whole idea what we have for going forward here. You may be asking, does that mean anyone can control it? Yeah, anyone can control it, but it's YouTube at the end of the day, so it's going to be pretty much closed down to pretty much. At first, I want to test it out personally. Then it'll be moderators. Then just select few just to see it. Then hope as we kind of get this whole idea going forward, we slowly relax it, because with great power comes great responsibility, and I don't know how people are going to abuse this, so hopefully not. And I do have a lot of trust in people, at least I like to think. So that's how we're going to go around doing it. So anyways, we send a command. Let's recap. I send a command on my keyboard, W, or say hi. This is sent, and this command is sent on the live chat. The live chat listens. We have a YouTube web server that's listening to. Basically, we have our own web server that's listening to our live chat by channel ID, and it goes, oh, he said say hi. So this takes this specific command, and as you can see at the bottom, it sends this as a payload to the Droiid server. You can see here that the payload takes the timestamp, the username, and the movement, or pretty much the response. So for example, if it said say hi, it's going to take that response. I can show you an example of a say response if I can find one. Yes, so we can see here in the timestamp username at SmartBuild said the message, hi, this is Droiid, I'm a package deliver robot, or say hi, how are you? And this is sent to the Droid's server, and the Droid server actually just does a bit of validation checks. And the checks here are mainly, is the person who says it, just basically, are they all who they say they are? Is the payload correct? In case someone tries to do something dodgy or so. And there's also, of course, there's like different checks. One cool little check I found was this profanity checker. So just in case some troll comes, it should filter it. But then again, YouTube and Twitch have got their own thing, so that's why. So this thing is kind of an interesting experiment, and we'll see how it works. Let's call this what they call it, a social experiment. But the whole idea is seeing how a community can react to a robot to interact with the real world, hence being Droiid. Yes, so this, going and recap it one more time on another tangent. We type in a robot, we interact with a robot using a keyboard, we can use our phone, we can use anything either through Twitch or YouTube, also locally. This, if we say hi, the server of, let's say the YouTube server, is listening to our YouTube channel by channel ID of the live chat of the message, is seeing the whole idea of say. If it hears the say command, it will say, oh, he said say this message. This message is sent to the Droid server where it's done some validation checks, as you can see here. The validation checks then go, oh, okay, this is genuine. Then it sends this data to our Pi, and the Pi also has its own proxy server, so that means we can it's via tunneling, so we are able to speak to the Pi, so the Pi is able to speak to it without being on a local network, so it can be accessed remotely from anywhere. And then this is just done by Droid at the node name, hence the node name for this smaller droid is called Droid/0. So we'll be able to listen on that URL and send messages. We'll go into this into a bit more detail, but the whole idea here is, now you may be asking, how is this built? How this robot is built? Now, this is what I've showed everything until now. Is pretty much the architecture of it, so just the software architecture. But let's go into more detail into actually the building of it and the actual robot. So before that, I'm actually going to go and get the robot to show you what each part corresponds to. All right, let me just wear my headphones. So what we have here is a smaller version of the robot, and I kind of built this to explain the larger robot. So this is exactly the same thing, but it's on 4 wheels rather than 6 wheels. So if picture another set of wheels and then just a larger chassis so that it can take a payload. So you can see here what this part corresponds to. It looks like there's some, hold on, let me remove this. I don't know how long that has been there for. Give me a second. Okay, it looks like it was a transparent backdrop, but let's just remove that for a second. So what we have here is the robot. Now the robot is pretty much got 4 motors. This one is kind of to indicate how it is. You can see that here we have some motors. These motors are attached to a wheel. And what we're using is an Arduino to actually control the robot. It will send pretty much a PWM signal to the motor to turn it. And how we're doing this is with the motor drivers. We have the motor drivers here. Now the reason why we're using motor drivers is because it can control the speed and direction of the robot. Because if we don't use a motor driver, we won't be able to make it go slow. It basically controls the voltage of the robot, of the motors, and regulates it. If we don't have that, we're just going to have a battery, and if the battery is just connected to the motor, that's just literally a whole 12 unregulated volts going straight, and that's not the best thing to do. So that's the whole idea. We have an Arduino. The Arduino, in fact, is getting messages from the Raspberry Pi. So remember the Raspberry Pi being its own server. So it listens to, the Raspberry Pi is always listening to the Droiid server. And the Droiid server is sending a message to the Raspberry Pi. Raspberry Pi says, okay, so the Droiid server would send this message, for example, it wants to go forward. This is sent to the Raspberry Pi. The forward message is then sent to the Arduino Mega, and the Arduino Mega is just this thing here, which is almost the brains which control the whole robot. And this is then sent, the Arduino Mega then just does a simple command like motor left, and it will send them, it will move the motor left, for example, if it was to go right. Because if we move in the left motors, it will move right. And if we move the right motors, it will move left. It's counterintuitive. But in this case, if we're going to go forward, all motors will start moving forward. And that's the whole idea of how it works. So a small little demo again. If we go into Droid mode, if you see here, and we see here once again, if we say hello, what you see here is the exact same thing here. We typed in a command right here. We typed in a command in, and it's sent as a JSON payload. This is our server is always listening to this command, and within, if it's a valid command, it's sent to the Droid server, which does a bit of some data processing and checks. It then sends to the Raspberry Pi, and the Raspberry Pi this goes, oh, okay, he said hello, let's send this to the speaker actually, and it says hello. And you can see that we're using a camera, and we also got a microphone on board. Now, if we're going to move forward, let's try move forward as a command, and let's just demo that. Let's move forward without crashing it. It's probably going to crash, but let's try. Okay, just stopped right before then. So we see that when we try W, it starts to move forward. And what we have here, if we just go back into the actual coding, we see here that we type in the YouTube, on YouTube or on our local, we type in the live chat W. This is sent as a payload, which is they go, oh, okay, he typed in W. This is then sent as into the server for some validation check. And then it's then finally sent as a payload to our Raspberry Pi. And I can see that we don't even have the cursor showing, so hopefully you can see on the top right a small thing saying Raspberry Pi. The Raspberry Pi then move forward to the Arduino Mega, which is then listening on a serial of the baud rate 9600, and then what's then done is that he said W, and it interprets W as forward. And if it's just a simple if statement saying if data equals W, motor forward. If data equals A, motor left, so and so. So that's pretty much the whole idea of the robot and how it works. That's my TED talk. So pretty much that's how we're gonna go around it overall. The next steps is I'm gonna do a live stream later, hopefully this week or early next week, along with an actual video release of how the robots came together. Now, if you would like to see, I've just got a bit of a snippet of the actual robot. If you would want to see that, let's have a look at displaying this, if I can. And this is exactly why I'm working on the second channel, because I'm trying to understand how we can put this all together. I need one of those, definitely those stream decks, so we can go in between streams at the moment. At this point, you're just gonna have to watch me fumble all of this up. So yeah, this is pretty much the video overall. I'm just putting this together. So let's start off with the robot and how it's built, if you would like to see. So you may be wondering how this robot is built, so let's actually have a look at it. So this is kind of the beginning of how it starts off. I don't know if you guys can hear. So that's the robot going, the one we just explained. And you can see here that we got the Droiid package delivery robot and the Droiid Mini here. And this is just an example to show the difference between the smaller and larger robot. It's exactly the same thing, the same electronics, it's just one is on roids. And this is exact same, this is the simulation, well, not the simulation, but a 3D model of it. So I'll quickly just illustrate what's going on here. So we have here the motors and their main electronic components. And we have the main parts on the side. First of all, we start with the battery. And the wheels, which are attached to the motor shaft. And you can see we're using a 12-volt geared motor and a motor driver. And the motor driver advantage is that we've got the speed and the direction. By the way, this is still in, I'm still working on this, so you're going to see kind of weird edits. So this is the schematic we're using, but we'll go into more detail on this. Link will be in the description. And we're using this actual motor driver, which gives us pulse width PWM signals. So we can control the motor speed and direction. I mean the speed mostly. So this is the Arduino code. So you can see that on the right, as we explained, remember the diagram where we showed that the Arduino, the Raspberry Pi speaks to the Arduino. This is exactly what we're having. We're listening to the serial port. If the data in the serial port is left, then we're just making the motor, well, it's counterintuitive, but if we're going to turn left, we need the motor to turn right. We need the right motor to turn right if we're going to turn left, because left is this direction. So we need these motors to turn right to turn left, and if we're going to turn left, we need the right motors, basically vice versa. Now, pretty much what we see here is this literally is an if statement. It's as simple as this for now. Version 1, which is just basically gets the data, and if the data that is being typed in from our keyboard, well, is W, which the data processor within the Droiid server, which just converts it into a left. So if the data is left, it just moves left. If it's right, it moves right. Now you see here this number. This is just the duty cycle of the PWM, so how long it should stay on. Is 0 to 100 at the moment, so 60 is just above halfway. So this will make the motors move quite fast, and this is clockwise and counterclockwise. So for example, these motors have to move in a certain direction and these in the opposite for it to all move straight. It's just something that is just as is, because if they're all moving in the same direction, this is just reflected on the other side, so it needs to be the opposite way for it to move. So you can see that it reverses and we can stop it. So this is the robot getting us a bit of water. So with that said, we go into the assembly of parts. Now the assembly of parts is just basically given how the robot was built. So you can see here, this is the direct dimensions. You can see that the robot consists of 3 main parts. The top base, I'm gonna put this on mute because I know if it's been playing out loud, it's gonna clash with the music we have in the background already. So this is just pretty much how everything's all put together and how the robot is put together. We're gonna sand it down. We're using a bit of wood filler. Wood filler is great to like get rid of make it all into one body. So that's pretty much how the robot is. Of course, we're putting the robot all together and all. And you can see here that these are the lights. So you may be wondering how this works. We'll go into more of a example of it. Yeah, this is the previous. This is the light vest. So this is a bit of the game theory behind it. These are the commands, as you can see here. Forward, left, right, reverse, X to stop, and text to speech is same message. Now it's kind of Super Mario themed. And that's the platform we're just gonna click on. You can see that the actual robot camera is here, that small little thing here. So let me just explain quickly. So what we're doing is typing a command, and this is sent to the Droiid server, and this message is then received by the robot. So for example, we say the message, "This is Droiid, I'm a package delivery robot, hello YouTube." We get this payload. And using the text to speech, we can alter the pitch. Now we're just, as said before, we're using this kind of small library, which is a profanity checker, just just in case there's any trolls or anything. We're just checking the message. It's a basic checker. It's nothing too serious. And this is just the software. So, for example, if we type in W, S to reverse, 8 for left and right. This is what happens. We're sending this message forward and it's been received by the robot. But let's go into what's inside the robot. You can see that we have a Raspberry Pi and we have an Arduino. What we have is an actual USB connection. And this is what we've explained before. If data is sent reverse, it reverses. The commands to stop the whole robot together, and all of this is working together almost like in an orchestra style, where we have the composer and we have the musicians. And this is a bit more of how it is. Now I know this pretty much is quite technical, but this is pretty much as deep down as we're going to go to. So if you're really interested in just this kind of low level detail or so, this channel is more focused on it. But on the other channel will just be more of just basically how it works. It'll be more on just on the DIY components, and as well as there'll be future videos of the actual robot out in public and getting deliveries or so. So we leave it. This is kind of the separation of the channels. So this place is more of just me just talking us on this. Now, if you guys got any ideas of how to improve this, please do let me know in the comments below. As you can see, this is kind of an early version of the robot, and there are some things that can be improved. A lot of things can be improved with the robot. So that's the whole idea of Droiid. And of course, this is just Droiid 1. This is Droiid version 1. I don't know what to call it, so I'm just going to call it Droiid. In fact, I think my camera's even telling me I've kind of recorded enough. So yeah, that's pretty much all. If you like this content, I forgot to say, please drop a like, subscribe, consider subscribing, and turn post notifications on. If you would like to see me ramble for like a whole hour of how this is built, this is the stream for you. Also, consider subscribing or joining the Patreon. It just helps fund the projects, if anything. So yeah, if you got any comments, please let me know below how it works. And my name is Evan. Thanks for watching. Peace.